I'm going to work out several of these problems on the Chapter 8 review worksheet that I gave you today in class. I'm going to start with questions 3, 4, and 5 over here. And if you want to try them out yourself, you can. It probably would be best, but if you want to just follow along. Number 3, the graph of y equals log base 4 of x. Well, we did this on the first page of our Chapter 8 notes, but you can just put into y equals into your graphing calculator log base 4 of x, because the log base is alpha window, option 5, log base 4 of x. And if you take a look at that graph, that's what it looks like. And it says it lies entirely in which quadrants? Well, this is quadrant 1, and it goes down a little bit into quadrant 4 because the quadrants are numbered 1, 2, 3, and 4. So it's quadrants 4 and 1, option 4. Number 4, you have to take this log expression and you have to expand it and then replace x with log of a with x and log of b with y. So this is the log of ab raised to the 1/2 power, because that's what the square root is. And then the 1/2 comes out in front, so it's 1/2 log of AB. And then the log of AB is the log of A plus the log of B, so it's 1/2 of the log of A plus the log of B, says the product rule. Well, the log of A is x. The log of B is y. So if you distribute the 1/2, it's 1/2 x plus 1/2 y, option 3. Number 5, you have to rewrite this in exponential form, which says x to the power of 1/4 is equal to 3. To get rid of the 1/4, you raise both sides to the reciprocal of 1/4, which is 4 over 1. So x is equal to 3 to the 4th. 3 to the 4th is 81. If you want to put that in your calculator, you can. Number 7. If the log of 6 is a, then the log of 600 is what? Well, what's the difference between 6 and 600? Well, 600 can be written as 6 times 100. And this is the product rule, which says this is the log of 6 plus the log of 100. Well, the log of 6 is a. And the log of 100, well, this is base 10. And you can actually, if it's just a plain old base 10 log, you can use your calculator. The log of 100, it's actually saying 10 to the what power is 100? Well, 10 to the 2nd power. So a plus 2 would be the answer, option 2. Number 9 is next, which is not in the range of y equals log base 5 of x. Well, if I have a domain and range question, the easiest way to figure that out is to look at the graph. So I've already got log base 4. I think I'll put log base 5 in my calculator. Take a look at the graph. And what is the range? Well, actually, this graph, if you look at page 1 of your Chapter 8 notes, where we graphed a log problem, this part of the graph actually goes down forever. It gets closer and closer and closer to the y-axis, never touches it. And it goes off to the right forever, and it goes ever so slowly up forever. So if I was asked about the domain of this, the domain would be x is greater than 0. You should see that on page 1 of your Chapter 8 notes. X is greater than 0. But the range is all real numbers because this goes down forever and slowly up forever. So what is not in the range? Well, everything is in the range. So this is how they would write it. The range is all real numbers. That's their fancy looking R. Now, if they changed this question around and said what is not in the domain, well, -2 is not in the domain because you can't have a negative value for x. And 0 is not in the domain either. So there would actually be 2 answers to this question if I asked you about domain. Number 10. What is the inverse of log base 4 of x? Well, log base 4 of x is the same thing as 4 to the power of y is equal to x. That's what that is. Well, the inverse is when you switch x and y. So if you switch x and y, you get 4 to the x is equal to y, which is option 2. Number 11, what's not equivalent to log of 36? Well, the log of 36 is the log of 6 times 6, which is the log of 6 plus the log of 6, which is 2 times log of 6, which is option 2. Well, that is equivalent. 36 is also 9 times 4. So the log of 9 plus the log of 4 is equivalent to that. So 2 is equivalent, 3 is equivalent, and 36 is also 72 divided by 2, which is the log of 72 minus the log of 2, so that's equivalent. So the only thing that's not equivalent is option 1, because that would say the log of 2 to the 6th power, and 2 to the 6th power is not 36. Moving on to question number 15. If you know the values of the log of 2 and the log of 3, well, you can figure out any log values as long as it's a multiplication or division or power of 2 or 3. Well, the log of 6 could be equal to the log of 2 times 3, so you can find that. The log of 8 is the log of 2 to the 3rd power, so you could find that. The log of 12 is the log of 2 times 3, so you could find that. Well, 7 is not any combination of 2 and 3 multiplied or raised to a power. So the answer would be option 2. You cannot find log of 7, but you could find any of the other 3. Number 17, if the log of 7 is a, what's the log of 490? Well, how do 7 and 490 relate? Well, the log of 490 is the log of 49 times 10. So that would be the log of 49 plus the log of 10. Well, we know what the relationship is between a 7 and a 49. The log of 49 is the log of 7 squared. And you can bring the 2 out in front. So this would be 2 log of 7 plus the log of 10. Well, if the log of 7 is a, you're talking about 2a, and the log of 10, you can ask your calculator, but the log of 10 is 1. So 2a plus 1 would be the answer to 17. Number 19, you can rewrite this exponentially. X to the negative 4 is equal to 625. So if you raise both powers to the reciprocal of negative 4, the reciprocal is negative 1 over 4. So I think I'll pull my calculator out because I don't know what 625 to the negative 1/4 is, but my calculator does. So 625 to the power of negative 1 over 4 is 0.2, and I'm going to do a math frac. So the answer is 1 over 5. 625 to the negative 1/4 turns into 1/5, option 1. Next one I'm going to do over here is question number 13. Here we have 2 logs separated by a plus sign, which means they can become 1 log. The base is x, and now you multiply 5 times 20. 5 times 20 is 100. And now we're going to rewrite this exponentially. X to the 2nd is equal to 100. And I hope everybody knows that you take the square root of both sides, so x would equal 10, option 3. Number 21, for what value of k will the graph of log base 7 of x contain the point 1 comma k? Well, I think I'll see the graph of log base 7 of x. And they're saying when x equals 1, well, I can look at the table of values. Oops. Sorry. If I look at the table of values, when x equals 1, y equals 0. So k would be equal to 0. 1 comma 0 is on that graph. Number 22, if y is between 2 and 3, Well, let me put in a 2 in for y. So 2 is equal to log base 10 of x, which means 10 squared is equal to x, which means 100 would be equal to x. Now if I plug in 3 in for y, I would get 3 equals log base 10 of x. And if I rewrite that, 10 to the third is equal to x, 1,000 is equal to x. So x must be between 100 and 1,000 if y is in between 2 and 3. So it would be option 3. Number 23, I could just run through all of these on my calculator. Log base 10 is just the regular log button. Log of 1, is that equal to 0? Yes. So that's true. Log of 0. What happens when you do a log of 0? You cannot do a log of anything unless it's a positive number. So the log of 0 is not equal to 1. This is not true. Option 2. 24. If I know the log of 49 is this number, what is the log of 7? Well, I'm going to change 49 into 7 squared. So the log of 7 squared is 2.542. I can move the 2 down in front. So 2 times the log of 7 is equal to that. If you divide both sides by 2, then you get what the log of 7 is. 2.542 divided by 2, which is 1.271. Option 2. Number 25, if the natural log of 17 is equal to h, what's the natural log of 17e? Well, here we got it. Sorry. Picking up from when the bell rang. The natural log, which is the log base e, of 17e is the natural log of 17 plus the natural log of e, because that's just the product rule. Well, they're telling us that the natural log of 17 is h, and the natural log of e, well, this is log base e. Log base e of e means e to the what power is e, or if you want to just pull out your calculator and do a natural log of e, e can be found on second divided by or second ln, but second divided by since e is not raised to any power. So the ln of e is just equal to 1. So that's h plus 1, option 2. Number 29, no matter what, if your base matches your argument, like if you have log base 7 of 7, or log base 10 of 10, or log base e of e, it doesn't matter. You can pick any number you want. I'll show you the log base. Let's say the log base 6 of 6. No matter what, 6 to the what power is equal to 6? To the 1. So no matter what, if this base matches this argument, the answer is 1. I can show you with another base. If you have log base 9 of 9, it's still going to be 1 no matter what, because 9 to the first power is equal to 9. 6 to the first power is equal to 6. So that's equal to 1. Number 30 we did in class. Let's see, what's the next one? Number 32. 32 says if f of x is log base 3 of x, what are the domain and range? Well, we've looked at a couple graphs already. So if we want to do log base 3 of x graphically, or you can look at page 1 of your notes. Remember that the range is all real numbers because this goes down forever and it actually slowly goes up forever. But the domain is x has got to be greater than 0. So domain, x must be greater than 0. Range, the range is y is all real numbers. So take a look at your notes, page 1, to see that one. Number 34, the log base is x minus 2. So rewriting this exponentially, you get x minus 2 to the third power is equal to 125. Well, to get rid of the third power, you're going to raise both sides to the reciprocal, 1 over 3. And 125 to the 1 over 3 is the cubed root of 125, which is 5. So x minus 2 becomes just plain x minus 2 because the 3 and the 1/3 canceled out. X minus 2 is equal to 125 to the 1/3, which is equal to 5. So x is equal to 7. You can check that out if you want to. And I think that's about it. Good luck on tomorrow's test.